Bismillah Rahman Rahim. In this session, we will discuss waves and we will describe waves and various terminologies associated with waves. So, the term used to describe waves can be explained with the aid of a displacement and distance graph. So here on the y-axis we have this displacement, on the x-axis it is called a distance. So in this graph, figure 3.13, a displacement and distance graph for a wave at a particular instant is given, and it shows at a certain instant of time the distance move. So the distance move from their undisturbed position by the part of the medium vibrating at a different distances from the cause of the wave. So in this shape we see this is disturbed position and this dotted line is undisturbed position. These particles are vibrating at different positions. So this is the shape of a wave. Or the first term we describe is the wavelength of a wave, represented by a Greek letter lambda, is the distance between successive crest. So here we have this point, peak point is a crest. So from this crest to the next successive crest is a wavelength. Similarly, the point at this point is a trough. So the successive trough is also a wavelength. Similarly, point A to C, which are in same phase, is also a wavelength. Similarly, from point B to D, which is in same phase, is also a wavelength. Similarly, from C to this point E or whatever is also a wavelength. Similarly, this A to C is also a wavelength. So the number of waves that a wavelength can be measured. So frequency, the next one is the number of waves that pass through this distance from any particular point in 1 second is called the frequency. If suppose this from this point to this point, it takes 1 second to pass through these waves from any particular distance. So this is in this duration, 1 second, this much number of waves are passed through. So we say that this is the frequency. So if two wavelength is passes through in 1 second, then we call it 2 hertz, or 2 number of waves per second. So that is 2 hertz here in this case. If 50 number of waves, like in AC signals in our home, is called 50 hertz. Similarly, if this waves in 1 second passes, the number of waves that passes, 10 waves passes in 1 second, then the frequency becomes 10 hertz. If 5 waves passes, then we say the number of frequency is 5 hertz. So here in this case, if we assume that from here to here it takes 1 second, then we say that the frequency is 2 hertz. Now the wave speed. The wave speed is the wave is the distance moved in the direction of travel of the wave by a crest or at any point in 1 second. So the distance moved in 1 second is called wave speed. The number of wavelength multiplied with the frequency, we get the wave speed. And the amplitude is A is the height of the crust or the depth of the trough measured from the undisturbed position what is carrying the wave, such as the rho. So here this is small a, from undisturbed position to the peak position is called the amplitude. Similarly, on the trough side, this undisturbed position to this point is a amplitude. Now let's summarize it. Wavelength is the distance between two consecutive identical points. The identical point could be a crest, could be a trough, could be a point A and C, could be a point B and D, or from this point, midpoint from here to here, or from here to here. Anything could be considered is a wavelength. Similarly, frequency is the number of wavelengths that passes a point per unit time, as discussed, and amplitude is the maximum distance from the mean position. This is also discussed from mean position. This is undisturbed position is the mean position, and this is the maximum position. Similarly for this one. Now the phase, the short arrow at point A, B, C, D on figure, this show the direction of the vibration of the part of the rope at these points. So here we can see in this phase, this point A and point C, these are in the same phase. Similarly, point B and point D are in the same phase. So this is the phase. So from point A to point C, because they are in the same phase, this is the wavelength. And here the vibration particles are in the same phase. So here we are decreasing, and these waves are traveling like this. Here it is decreasing. From here it was going like this, from this point to this point, and similarly here again here. So this is are in same phase. So here again, here moving like this, here again moving like this. So they are in phase. This point is in phase. So in the next session we will discuss wave equation.